So the interview is to gain a perspective and an understanding of your perspective on science outreach and on your own research, just in general.
Okay.
And so we start. Could you explain your research project in 3 sentences?
3 sentences. Okay, so my research project involves the evolution of the brain, which is an organ related to many innovations in vertebrates. For example, the neocortex in mammals that is particularly representative in humans. It's what everyone knows as brain, and. But there is unclear what innovations correspond only to mammals or only to amphibians or only to fishes. So we think that there's a pre-existence of cells and some genetic molecules in the most basal, in the most simple, in the simpler vertebrates that exist. So what we want to do is you want to wait. So what we want to do is to compare these molecules between 2 groups of vertebrates, the simpler one and a really how do you call it? A mammal, which represent the newest vertebrates right now. And we think that we will find pre-existence of these cells in the most basal one.
Okay. Now imagine I'm your friendly, not knowing anything about Evocell, neighbor. Could you tell me what your research is about?
Okay, so I will maybe say the same. So, okay, let me see what I said. So, okay, the brain is again an organ to represent is of main importance in many animals, but especially in humans, for example, is the responsible of the creative characteristics or making music, emotions, these kind of things. So it's particularly the origin of the human brain, for example, is a really old question in evolution, but also in humans, in human history, because since it was supposed to be the center of the soul many centuries ago, many people have wondered where the brain comes. The problem is that in classic neuroscience, people tend to study humans, isolate them. So if we want to know what's new in humans, we need to study the rest of the animals. So my project, because one person cannot study all animals, but my project is to study the origin of the brain, the evolution only in vertebrates, which is the big class to where humans belong. And so I'm using really old species of vertebrates called lamprey. This is a fish that doesn't have jaws, and not many people like them because physically they are not nice. They are parasitic, so they are. Maybe the biology of the idea of lamprey is not the best in common culture, but these animals represent a really old species. So it's probably what we find in this animal is probably what the ancestor of all vertebrates had. So my idea is to compare. I want to study molecules. What molecules determine the brain in the lamprey and in a mammal. I have chosen mice. Maybe it will be human in the future. To see what is shared between these 2 species and reach the ancestor of the vertebrates. And in the future maybe identify what is actually new in mammals or in humans.
Okay. What are for you the most important points of your research?
So I think the impact of studying these invertebrates is really high because many people have already studied lamprey and mice, and there's a lot of controversial theories of what they share and what they don't share. Mm-hmm. So the brain is apparently the brain evolves really slow. Yeah.
Okay, I'm continuing now.
Well, I was saying that one of the most important points is for me the fact that there's many when people have studied these animals, there's many still controversial theories of what was present in the ancestor of vertebrates and what was not. For example, the cerebellum, which is the control of the motricity in higher vertebrates, including us, is unclear if that's an innovation of higher vertebrates or was present in the ancestor. And so I think that unraveling this project, because of the data we're using, can get really important insights in denying or accepting some theories. But this is just basic science. This is the contribution to knowledge.
Yes.
I guess all other points is that because we are producing RNA, which is part of the genetic expression cascade, is we can manage to identify which genes are expressed in, for example, humans are not mice, are not lampreys, and some of these genes are associated with diseases. There's some genes that we work in lamprey that doesn't cause any trouble, but is associated with Alzheimer, for example, in humans. And but in a personal level, I also think that because the technology is so new, it requires the work of scientists from many areas, not only biologists, classic biologists, but also statisticians or people working in physics, bioinformatics. So it's also the multidisciplinarity that we're using. I think is now in science is important to just not one person working in all areas, but working with many people whose expertise is in different areas. So,
no, that's good. What are the 5 most important words for explaining your research?
Words.
Yeah.
So
So words to explain your research that need to be understood.
I will use brain evolution, cell evolution, cell identity, genetic modules. Well, these are not words, but that's concepts, right? And RNA expression.
Yeah. And now, how did you become interested in cell type evolution? A researcher. Yeah.
So, I always, not always, but before I was working in species evolution, let's call it that, in patterns of diversification and speciation in a species.
Yeah.
And it really caught my attention the fact that now these new philosophies and science are proposing a similar concept for cells, but it's really, even though after hundreds of years in species studies we don't truly understand what a species is or how they speciate and develop and isolate, in cell type identity evolution or cell type evolution, this is still like, maybe this is become the first actual studies within an evolutionary framework. So I think there's so much to do. Nothing is completely clear. So